All right, in Mod 1, Day 1, we talked about recognizing patterns. And in Day 2, we're going to do sequences, which is kind of the same thing. It's recognizing patterns, but this time maybe instead of pictures, we're talking about numbers. So here's the definition of a sequence. It's an ordered list of numbers, which means it's a list of numbers in order, first to 10th or first to last. And it definitely follows a pattern. So here's an example of a sequence. This is a sequence I made by starting with the number 2 and then adding 3 each time. That's a pattern. Here's another sequence. This time I started with the number 3 and I multiplied by 2 each time. So these are two very simple patterns, easy to see. Sometimes the pattern is a little bit trickier, a little harder to see, but there always is a pattern to every sequence, no matter what. So here's some vocabulary I want you guys to know. Number 1, each number in a sequence, we call it a term. And we're going to use the letter A to represent each term, a lowercase a with a number after it. And the number after it tells you which term we're talking about. So if I'm talking about A1 in one of these problems, what I mean is the very first term of the sequence. And if later on in the question I talk about A6, that means I'm talking about the 6th term in the sequence. So if you look back at that sequence and you count here, 1, 2, 3, 4, 5, 6 spots forward, that's A6. So basically our sequence goes A1, A2, A3, A4, A5, dot, dot, dot. Keeps going for as many terms as there are, we're just numbering them. Now, AN is basically our variable. So like when we're working with numbers, our variable is usually X. This time we're going to have AN. AN could be any term. It means maybe I'm talking about A1, maybe I'm talking about A10, maybe I'm talking about A100. It's a variable that represents any term. And usually what we do for AN is a formula that lets you find the terms. So here's an example of an AN formula. If I told you, for example, that AN equals 3n plus 5, that's how you find any term. If I want to find A10, the 10th term, I can substitute 10 for n and see what I get. If I want to find the 100th term, I could substitute 100 for n and see what I get. So that's really what AN is. It's a formula that lets you find any term you want. So let's start with an example. Let's use that same formula I just gave you, AN equals 3n plus 5, and let's write the first 5 terms of the sequence below. So I'm going to find, actually not all 5 of them, you'll see what I'm going to do. But let's find A1 first. Now remember, this n right here, whatever number here, I substitute for n here. It's like kind of like using f of x. So if I want to find A1, I'm going to substitute 1 for n. That would be 3 times 1 plus 5. 3 times 1 is 3. So it's basically 3 times 5, which is 8. So the first term in my sequence is 8. Okay, let's find A2. So this time I'm going to substitute 2 for n. I'm going to have 3 times 2 plus 5. And I say, well, 3 times 2 is 6. 6 plus 5 is 11. Now let's find A3. So this time I do 3 times 3 plus 5. 3 times 3 is 9. 9 plus 5 is 14. So the next term is 14. So there's 11 here. Now remember I said I can finish this out. I could find A4, put the number in, I could find A5, but once you've found 3 or 4 terms, if you can see the pattern, you may not need to do that, because right now if I look at my numbers, I have 8, and then 11, and then 14. It looks like I'm adding 3 each time. So instead of doing the work the long way, let's just add 3 again. 14 plus 3 is 17, and one more time, 17 plus 3 is 20. And that right there is the answer to our question. Those are the first 5 terms of the sequence. Now, just to show you that it would have worked, if I did do it the other way, if I found A4, which would be 3 times 4 plus 5, I would say 3 times 4 is 12, and 12 plus 5 is 17. So I got that answer there. And if I did A5 that way, 3 times 5 plus 5, 3 times 5 is 15, 15 plus 5 is 20. So you can see the extra work I did in blue, I switched color to show you that I probably wouldn't have actually done the problem that way, but you could have. You know, if I asked you to find the first five terms of the sequence, you can plug in the numbers 1 through 5 and get those 5 numbers. Or you can find 3 or 4 of them and use the pattern to find the rest. But that's our formula for AN, and that's how you can use a formula to find terms of a sequence. All right, so for our next example, what we're going to do is, first of all, more of a writing question, and then we're going to continue the sequence on from there. So the first thing says, explain the pattern in the sequence below, and then tell the next 3 numbers. So when I look at this, the first thing to do is to recognize a pattern, and we start off with some negatives, which is a little bit tricky. But after you look at it for a little while, what you might notice is the pattern is that we are adding 6 each time. So like if I take negative 8 and I do plus 6, I get negative 2. And if I take the negative 2 and add 6, I get 4. And then you get into the positive numbers. It's a little easier to recognize. 4 plus 6 is 10. 10 plus 6 is 16. So for the explaining part, explain the pattern, I would say you're adding 6 each time. Now, once you've recognized the pattern, the second part of the question is actually it's the easy part. It's saying, now, tell me what those next 3 terms would be. We'll just keep adding 6. 16 plus 6 is 22. 22 plus 6 is 28. And 28 plus 6 is 34. So once you've done the first part of that question, the second part is actually easier. Let's do one more of these, and we'll be done for today. So same question. We're going to explain the pattern, then tell the next 3 numbers. And I gave you a trickier one just to show you that the pattern isn't always we're either adding or multiplying. You can have different patterns. And I gave you a hint. I said this is like the B problem from last week. So when we did pages 7 through 10 out of the book, we did the question about the B problem. And what I said is, if you look at this carefully, what we're doing is we're using the terms to create the next one. So basically it starts with a 1 and a 1, and this is the one where if you add any 2 numbers, it gets you the next one. So like 1 plus 1 gives me the 2, 1 plus 2 gives me the 3, 2 plus 3 gives me the 5, 3 plus 5 gives me the 8, and then it keeps going from there. So that's your pattern. What you're doing is you're adding each 2 terms to get the next term. Then once you recognize that, remember, once you've found the pattern, finding the next 3 terms is the easy part. So to find the next term, the next blank spot I just drew in, I would do 13 plus 21, and that gives you 34. And then to find the next one, I would do 21 plus 34, and that gives you 55. And then to find the next one, I would add the 2 I just made. I would do 34 plus 55, and that would give you 89. And those are your next 3 terms.